you will see that the LED will turn on. Okay, you release it, LED will turn off. Okay, what happened actually? Actually, this is the input. Right, you got the input whether 1 or 0, whether 0 volt or 3.3 volt. And then if you got 1, so you will you can decide you want to control, okay, the output. Okay, what happened? I just take out this pin, which is the D1, right? What happened if I put 3.3 volt? What happened? It will turn on the LED, right? You will see. What happened if I put it ground? It will turn off the LED. See? This is what I'm telling you is the digital input. Only it will accept whether 1 or 0, 3.3 volt or 0 volt. Do you know what I mean, right? You can turn on, turn off. Okay? Alright. So now, let's say we have a sensor. Okay. Alright. This is the IR module. Okay. Now this is the part that I'm not cover during the my YouTube video lah. So but I have slide here. Later on you can get this slide from me. Oh, I don't have the IR module. I have another example. Okay, it's okay. Alright. This IR module, it use Allah. Wait, yeah. How to I share this one? How to share this one? Okay. So this is the IR module, right? So the output from this module will be digital, whether 1 or 0, whether 3.3 or 0 volt. Okay. So this one we call it module. This one we call it a sensor. It have the transmit and it have the receive. So if you buy only the sensor, we call it raw sensor, only raw, right? Only the sensor. When you build the what we call it the module that have some ICs, or we call it comparator, and also you have some resistor to set the value, right, for this IC and so on. So this one, the whole part, we call it module. Okay, so let's say what is the pin is involved. So this is the VCC where you put the supply. In this case is 3.3 volt. This center is the ground where you put the ground. Alright, this is the output, is the data that coming through this sensor. So the data is whether 1 or 0, digital data. Okay, so now let's put. So you can have, like here, you can have this one, this cable, we call it this one, the female, right? This is the female, and this one is the male. You can have the cable female to male, right? Or you can have the cable male, and where is the, yep, and male to male, and then you can have female to female. Okay, and then you can put it together lah, alright, depending on your circuit. Okay. Alright. Okay. So now what we're going to do is we're going to connect the RR module, this one. Okay. You put it here. So I put it, I'm using the female to male connector. Put it here. And then this one I put it here. Okay. Alright. So we know the input only 1 or 0. Alright. So that means you will put it into the digital pin. Okay, let's say we put at the same pin, alright, where you put the switch. Okay, so now VCC connected to 3.3. Okay, the purple, so connected 3.3 here, 3.3 here. Then after that, ground, the what the color is it? We call it. Okay, then we put it ground here. You see, it will turn on the LED module, right? The IR module. Now, this pin, you connected to the input pin like we had configured before, which is D1. Okay. Now you will see the LED will turn on. So LED will turn on, that means what happened? At this pin D1, at the sensor value, is it high or low?
High.
High. Okay, correct. Okay. That means now I don't have any object here, is high. So when I have an object here, it will be low. Okay. This one, low. Okay. Did you get it? Did you get the concept? Alright. Yeah. So we are using the push button only to do some demonstrate, only to do some demo lah about what is the digital input pin. Same concept. Push and then you got one. Right? This one also same concept. So you have solved your first module, right? IR sensor. You want to use this module lah. Okay. This module has been applied during when you go to the mall. You will see the temperature detector, right? So they use this module actually. That's why when you put it at the direct sunlight, so it will disturb your what we call it, your this light, right? This module, it will disturb. That's why when you put your head there, it cannot scan because of direct sunlight. Okay, so that's why they use it in indoor, right? And then they put some hollow there, right, to make sure you can cover the what we call it, the light, right? You can cover that one. Now, so okay, are you happy now? So happy, right? Done. IR module done. Okay. Because IR modules, we use the same concept, which is the digital input. Okay. Now, let's move a little bit about ADC. Okay. Maybe some of you will use the ADC, right? ADC module. Maybe we use the ADC value. Okay, can I ask you, anybody use the analog sensor? Who going to use the analog sensor? No? Okay, never mind. You want me to show it to you? You want me to show?
Yes. Yes.
Okay. Alright, good. I will show you. Never mind. So, analog sensor, now we want to focus on the analog, right? So, in order to simulate this one, so we use the potentiometer here, right? Potentiometer have a 3 leg here, okay. Then what happen is when you try to turn on, right? To it's not turn on, to rotate this one, it will generate at the difference voltage. For example, you put the minimum voltage is 0 volt until 3.3 volt, right? This one. So this value at the center one, it will give you the value between 0 volt until 3.3 volt. It depending on your rotation, this one, and also depending on the value, this one. Okay. Any question? No. Okay. So it doesn't have any what we call it polarity. This one you can put any positive or negative, okay, or ground. Okay. So how to connect this one? Put it here. Done. Okay, see that here. Okay, done. So now you need a 3 wire. The wire, right? I'm always use, if you play around with the VCC or positive supply, so make sure you use the right color, right? So that you know, oh, this one is the VCC of positive, right? Okay.
Doctor, what does VCC stand for?
VCC, time for voltage. What is the CC? I forgot
But
the
basically it goes to positive lah.
yes, correct.
Okay.
VCC it is mean the voltage for the not MCU. For example, VCC that's mean in this case not MCU can what we call it generate the voltage at the maximum 3.3 volt. So VCC is 3.3 volt. You will connect to the 3.3 volt.
Okay.
Some other sensor they use different name. They use VDD, Violet Denmark. Yeah.
Okay. Alright, thank you.
But the concept is same, right? VCC or VDD, it will be the same. Okay. I hope today you will get the idea what is the connection is about, right? Because we want to learn. It's not about learn about theory, so you need to be good in terms of practical. So this one also I put it here. I'm using the brown. Okay. So another leg, and then another one I use white color. White color that's mean like data. Okay, data line. So, right. So this one VCC. So I need 3.3, and you can put any line here. Okay. And the other one I need a ground. Put it here. And then this one go to analog. Analog A0 will be here. Okay, here. Alright, done. I'm done do the circuit. Any question about the circuit? No question. Any question? No. Today I'm going to show you until how to use the temperature sensor. It will be good for you, and then after that you can start to design your own project. Okay, so let me give you some little bit briefing about analog. What is mean by analog? Okay, this is your node MCU. Okay, this is your node MCU. Then this is the pin, analog pin. Okay, ADC. Okay, ADC, or the name is the A0. Okay, now you already put it the potentiometer here, 5 volt, and then this one is the ground. Okay, and this is the variable resistor. Okay, inside the potentiometer. T the symbol lah potentiometer. Okay, now you know that the voltage, right, going to the analog input, it will give you the voltage from the 0 volt until, oh sorry, this is not 5 volt. Sometimes got confused with another controller, 3.3 volt. Okay, so it will give you 0.0 volt until 3.3 volt. Okay, I put it until. Okay, now what happened? The ADC pin, it will convert back to the value. For this node MCU, it have 10 bit ADC. This is the word. 10 bit that means is resolution. So that means 2 power of 10 minus 1. So the maximum one you got it, this data. 1023. That means in this pin, it will convert from 0 until the digital data is 0. Okay. Until this one, it will convert 1023. The same method for PWM, but it will inverse lah. Right? PWM, we set here, it will produce here. We set here, it will produce here. Okay, 3.3 volt, sorry type. Okay. 3.3 volt. Okay, the same concept. PWM here, produce here. But the ADC, we read input. We read 3.3, it will produce this data. We read 0 volt, we produce the data. Okay, so if we read around 1.67, we will get the data 512. Okay, yeah. Can you see the concept? Alright, is it good? Is it clear? Okay, Alhamdulillah. So let me produce. Any question you want to ask any question that not clear for you, maybe you can ask. Okay, so let's share again. This one. Okay, done. So now let's create the coding. Okay. So I just open the coding that I wrote before. Where is it? Lead potential meter. Okay, done. So what is this coding is about is okay, how to extend extend. Okay, now I just use one analog input DC potentiometer at pin A0. Done. Analog pin no MCU only have one analog pin. Alright. If you use the Arduino, it can have 6 or 5 analog pin. Okay. And then LED, yep, is to use to simulate our output. So if you rotate this one at a certain value, we can control the LED brightness. Okay. So what we do the same method. I just call function analog read. Right? You see the word analog. What you want to do? Read. Okay. Alright. You read the pin A0, and then you save at this value, at this variable, sensor variable, and then this value you pass to the LED, which is you generate PWM. But that's why you call analog write. Analog write. Okay. So this value. Okay. And then you delay for 3 seconds. 3,000. Okay. Let's look. 30. Not 30 lah. 0.3 millisecond. Okay. So just right. Let's look what happened. Okay, now let's see. Writing. Guys, any question? Anything that you want to ask? Is it I going so fast? Is it okay? You can follow, right? Okay.
It's okay. It's okay.
Okay. Now you will see that. You see? You can control the LED brightness. Okay. Alright.
So,
Okay.
Doctor,
Yes.
why didn't we didn't put in void setup for the potentiometer?
Why? Why do you need what? Sorry?
So like input or the potentiometer, we should do input or no need?
Input. That's mean.
For
That's mean. Okay. That's mean. Okay. Potentiometer.
no need
Okay,
the
what?
input for the void setup.
No need the input. Sorry. I cannot get what.
So
what
like
your...
the lead we did put output. For the potentiometer, you didn't put input or output in pin mode. And the code.
Sorry, I cannot get it.
Okay. Doctor, I think he means at the code void setup, we have pin mode LED output. Why don't we have pin mode potentiometer?
Yeah, exactly.
I see. Yeah. Okay, good. I mean this one. Actually, you need to put also pin mode. Okay. And potentiometer. Good. Thank you. And is input. Okay.
Right.
Thank you guys. Thank you. Okay. However, if you are forgot to put the pin mode here, so if you call the function, then it will know that this pin, of course, is the input. Okay.
Oh, it's already input if you don't put it?
Yes. That's why it works.
Okay.
That's why it works.
Yeah.
Yeah.
I shocked.
But I think the correct one, you should put this
Should
one
put
first
it.
lah.
Yeah.
So do the first thing, and then this is the second thing, and then you can proceed right your coding.
Yeah.
Okay. Okay. All right. Okay. Let's say we want to display this data. So you can go to my next one is how to display the potentiometer data using the serial monitor. Okay, this one will be simple. So what you can do is you can write this one. There is one name serial begin. Okay, we choose the baud rate 600. Okay, and then after that we can display this value. Yeah, sometimes I also forgot how to write. Okay, okay. So now we can display the value. Okay, this is what you have learned in the programming class. For example, like printf and so on. Okay. Okay, so let's say we do like this one first. Okay, so that you can understand the coding. Okay, yeah. Okay, let's write this one first. So what it do is it will display the the reading, right, of the potentiometer, which is the ADC reading. Okay, 7, 15, 33. Okay, 61, 9, 8. Okay. Now, if we call this function serial, okay, what it do is from your node, it will send to your computer. Okay. Now, in order to open the serial monitor, you just go to this one, serial monitor. Okay. Now, if we go to this, maybe what you can do is you can add another one after it read. Okay. This one you put it is /n. /n, you know already, right? If we go to the new line.
Excuse
Okay.
me,
I hope that.
excuse me, Doctor.
Yep.
We cannot.
Yes.
We cannot see your screen.
Oh. Oh.
Your
Sorry.
device.
How
Cannot see.
people are viewing your screen, your device. So device.
Your bread.
Okay.
Your bread. No, your bread board. We cannot see. Cause.
Okay.
Okay.
This one. Okay.
Okay now. Okay.
Okay.
Now,
Okay. Good.
okay.
Okay. Now. Oh, this one you can see? No.
Yes. Okay.
The
You
COM
can see or not?
7?
Yeah, the com.
COM
Can
7
see, right?
is, yeah.
Okay, good. Okay, this is the way that I told you. This one, when I rotate at the maximum one, right, which is the at
3.3.
okay, so equal 0 volt lah. But normally there will be some noise a little bit, right? So when you rotate the maximum one, you see, it will go to 1024. Okay, right?
3 beyond 3. Yeah.
It should be 1023, right? So what happened? Why is 1024? It should be 1023, right?
I think 3.3 because 1024.
It should be 1023, right? I agree, right? Now it go through 1024. What happened 1024?
Can you
So
put
let's
as
see.
0 right there?
Huh? Sorry? It will not go to 0. It go to 0. Right now it go to 1024. It should be, if you want to test it, so what you can do is analog pin, you can short it to the 3.3 volt, 1024, and then this one you short it to the ground. Yeah, there will be some noise there, right? Okay. It should be 1023, but I don't know why it go up to 1024. Alright. But it's okay. Alright. It should be 1023. Anyone who going to have an idea why? Then let's look the potential meter. Then let's try this one. It will be any different. In this case, you already convert it into voltage actually. So using this formula lah. Okay. So this one divided with the 1023 and then you time with 3.3. So you want to display the voltage, so you can put it here. What happened? 1023. Right, let's see. Oh, the maximum is to 1024. Maybe I think it start from 1 to 1024, I think lah. Okay. But I think it's okay. As long that you know, okay, for the reading that you got it is the maximum is 102, what you call it, 24, alright, it will be okay. Okay. Alright. So this is the way that you write the coding lah. So if you want to get it, okay, if the what we call it, the sensor value, okay, equal or maybe less and equal to 700, you need to put it less and equal, because you don't know, because we cannot get exact value, okay, and then you can put it LED, okay, analog, right, equal to the maximum. Maybe you can put 0, okay, and then you can put your another program. If sensor value, what you call it, more than, okay, for example 800, like that one, okay, and then what you want to do, this is based on your coding, okay, maybe you want to make the LED brightness will be half, okay, like that one, maybe I put it at 1000, okay, maybe 700, more than 700. If less, it will make the LED 0. If more, it will make the LED come half. Okay, so right now we comment this one. Okay, let's see what happened. Delay is okay lah. Okay, let's see. Do you understand, right, what what I'm doing right now? So I just want to show you, if you got this value, so what you want to do. If you got this value, what you want to do. So this value you can set lah. Okay. Alright. If you play around with the analog. Okay. So this one, if the value is less than 700, so LED will turn on, turn off. If the sensor value more than 700, LED will turn on, but with the half brightness. Okay. So let's see what happened. Okay, now, yeah, this is half and off. Okay, and then let's say more than 700. 419. Oh, okay, half. Okay, it will half, right? So half. Okay, if I rotate 0, it will half. Okay. Any question, guys?
Doctor?
Yes, I am.
For the delay, we can cancel it, right? No need delay.
This one,
Yes.
you don't put the delay here, right?
Yeah.
Yes, sure. After that, we see a lot of data here lah.
Oh.
Okay. Alright. It's okay. Depending on your application lah, depending on the coding. If you don't put delay here, your data will be banyak. Alright. Too many
Infinity.
data. Yeah, infinity. Yes, correctly. Okay. This is the way when you want to check what is coming through here to your node MCU, right? Alright. So this is the way using the serial monitor. Okay, so last one. Servo motor done. And then after servo, we go to your temperature sensor. Alright. So and then we will end our class. I think it is enough for you to play with the other component. Okay, so let's say uh, uh, servo motor. Okay, so we have covered. Actually, we have covered three things. Okay, four things, which is the analog pin done using the potentiometer. If you play with the sensor that we produce the analog voltage, we have covered the digital input, which is the push button or an IR sensor, right, to detect the distance. Done. We have covered the digital output, right, which is the LED lah, right. Okay, and also we have covered the PWM concept. So analog pin, if we use the analog read. PWM pin, we use the analog write. Digital, we use digital input, we use digital read. Digital output, we use the digital write. Okay, that is the concept. Okay, now let's move to the servo motor. Okay, so far okay guys, is it too heavy for you? So far good. It's time for you to digest.
We try to go.
Okay, but I hope that you can understand what I
Yeah.
have explained. Alright,
It's
clearly,
enjoyable.
right?
Yeah.
Okay.
Yeah.
Okay. Now let's let's try to move this servo motor. Okay, this is the servo motor. I call it mini servo, right? The weight is only 9 gram, and the torque, you can see the torque, yeah, it's not here. It will be the small torque lah. So you can feel that, yeah, okay, the torque will be light lah. Okay, compare with other servo that I bought it. Which one? Okay, yep, this is the last servo. Okay, compared to this one. Alright, maybe I can put it here. Okay, alright. So this is you the metal. Oh, I cannot rotate this one. Right, turn on. Yeah. So that means the torque will be uh, higher lah compared with this one. Okay, so I will use this one. Okay, this one you can use the supply from the node MCU. Okay, if this one maybe you need another external supply. Alright, because the current, right, is produced from the node MCU is not enough to drive this servo motor. So if you are planning to use this servo motor, so maybe you need another external supply like power bank and so on. Okay, so let's move this one. Okay, so what you have, you will have the female, then you need the male. Okay. Okay, so let's look the connection of this one. So the brown go to ground, the brown. So this is the brown. So brown, let's choose the we already have here. Let's choose, okay, the brown is the brown. Okay, done. And then after that the red, okay, and then orange. This is the red. Okay. And then orange the white. Okay, done. So the brown is moved to ground. So here, and then the red color 3.3 here, and then this is data, so we can put it is D2. Okay, D2 0 1 2 D2 here. So done. This is our circuit. This is our servo. Okay, done. Alright. So now it's time to write the coding. Then you can close first. Sign close and open. So I already wrote the coding this one. Okay, done. Okay, now this is the servo motor. Alright. For the servo motor, it's already given. I mean the library is already installed in this Arduino. So you don't need to install this library. So you just call include servo.h, right? Include servo.h, and then you create another name. For example, my servo. You can put any names, right? And then this is the pin. So now I connected to D2, right? Okay, D2. Okay, right. So you don't have any LED. Yep, if you want to use the LED, okay, maybe you can put it integer LED equal to D7. Okay, done. And then in order to make sure the node MCU know that pin D2 is attached with the servo, so you need to call my servo attach. Alright, and another one we have the LED pin mode. Okay, and then MODE LED and output. Okay, thanks guys. Okay, alright, done. And then you just need to call this library, this function, myservo.write. This is the angle that you want your servo go to. Okay, alright. For your information, there are two types of servo, right? Servo motor. The first one, it can go from 0 degree to 180 degree. See here. Okay, 100. Okay. Oh, right. Another one, it can go to 0 until 360. Like this one, it can go to 360 lah ni. Okay, 360. Another one, it can go to 0 until 180. Okay, so in order to call the function, you just call myservo.write. So in this case, I put it the first, it will go to 0 degree, and then delay to second, and then it will go to 90 degree, delay to second, and then it will go to 180. Okay, now let's move your what we call it, let upload this program. Okay. Guys, are you still there?
Yes, doctor, we are here.
Yeah, okay.
Yes, Doctor, we
Still
are
there,
here.
right? Okay, good. Alright, so let's see. Yeah, another 20 seconds. Need to wait. Okay, now. Yep, 0, 90, 180. 0 again, 90, 180. Okay? Alright. So you can change the value, alright? 0, 90 or 180. Okay. Right. So now, let me modify this program. I want to put this sensor because you want to develop the hand sanitizing sanitizer system, right? Then you need to have the eye sensor and then your hand, right? And then you will move the servo motor, right? Okay, how to write this program? Okay. Now, according to this, the eye sensor, the purple go to 3.3, done. This one go to ground, done. This one we put it in pin D2, D1, sorry, D1. Okay, done. Okay, now I already connected this one, and this is your servo. Okay, so let's move. So now this one I put it integer IR sensor equal to D1, settle. Okay. Please help me if I miss something, this one. Okay. So now I put it, the configure, the pin. Okay, this one is the input. Okay. Now, first of all, I off the LED. LED, digital what? Digital, right? So LED equal to high or off low lah. Okay, done. After that, I have the one variable. So I read the, okay, before that, I make sure the servo go to 0 angle. After that, I call the digital read. So I read the IR sensor. So then, and then after this, right. Okay. So this one I will test. Okay, if the sensor value exactly equal to high, now I will move my servo. Okay. Go to 90 degree, and then it will delay for 2 seconds, and then after that it will go back to 0 degree. Okay. Right, so back to, okay, and then detect 90 degree, 2 seconds, then 0 degree. Okay, okay, something like that lah. Okay, that's mean. So each sensor equal to 0. Okay. Right. So let's test this one first. Okay. Somebody, if you have a good idea about the programming, yep. This one is what? If okay, semicolon here. Okay. If you see this error, this line, that means there will be an error there. So the error will be whether at this line, right, on this line, or whether before this line. Okay, this means the error will be at this. Okay. So you upload. Okay. Alright. 0, 20, 50. Okay. So now, okay. Alright, how to do that? Okay, we go back. Alright, see? Okay. So one, right now when I have this sensor, okay, so maybe I can put the LED. First LED will turn on, this one. High. Okay. Right. So when it detect, so and then it will 90 degree, delay 2 seconds, and then it will go back. Okay. LED high, servo, in high, not detect, then 90 degree, 90 degree, 2 seconds, come back, and So this is where you combine, okay? Where you combine with your IR sensor, okay? See. So this is where your, when you develop the hand sanitizer system, let's say, okay, now I already got the what we call it, the liquid, right? The sanitizer. Okay. Right? Is it okay? Why
Okay.
I feel that's lonely. Okay. Okay, right? So I hope I hope you can understand lah. So when when that's mean you don't have nothing here, then when you put your hand, so it will move. I see. Right? It will move. Right? You see? It will move. So that's mean you can put your servo motor to pull the lid
Sanitizer.
of the hand sanitizer. Okay, that is the concept where you combine the input and then this is the output. This is the input and this is the output. This is the only the what we call it indicator only, right? For you to know, okay, that's mean when you have hand, okay, you turn on, okay. This program I think inverse. I think you need to invert it, alright? Okay, but it will work lah. So it will depend on your coding. Okay, alright. Okay. So far okay. Is it okay? Yeah. Distance, this one. Okay, good question again. Okay, the distance, what you need to do is there is a potentiometer on the IR sensor, right? There is the potentiometer. If you see that, okay, this is the maximum distance it can detect. If you can see that, okay, this is the maximum distance, okay, all right. So if you want to adjust the distance, so you can adjust the potentiometer, all right. You can adjust this one so that, yeah, I think the maximum is only how many? Is it 5 cm? Okay. Alright. This is the maximum one lah. So and then you can adjust again. Do not adjust sampai do not adjust until you got the LED light up, right? This is the maximum one. Yeah. If you turn this one, it will light up, right? It will turn on. Do not do that. So until you need to turn it back, okay? So I think this is the maximum one lah. Yeah. I think this one will be far, a little bit far. Is around how many? It's not 10 cm. How about is it? 6 to 7. Okay. This one. Okay. So you can adjust the potentiometer. All right. Okay. 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 Very good. All right. Last one, right? Before we end our class lah. Last one. Okay. So far so good. Umama, do you have any question? Umama? No? Who's else? Just pick one. Who's else? Ahmed? No question? Okay. Alright. So far so good. Okay, good. I'm glad to hear that. Okay. Now, I'm going to show... Wow. You are watching football, right? Okay. Now we're going to learn about MLX 90614, which is the temperature sensor. Okay, this is the sensor that I suggest you to buy. Okay, this one. So this is the spec lah. Alright, the description, it can detect 40 to 125 and so on. The good thing about this sensor is it's already calibrated. Alright, so that means you don't need to do the calibration again. Okay, no need to do. Okay, So before that, okay, let me show you first the sensor. Okay, let me pull out all these things. Okay, right. So where is my sensor? Yeah, this is the sensor. Okay, all right. So the sensor has 4 pins. Okay, that's why I told you. When this sensor come out with a certain board, right? There are some IC and resistor there. So this one we call it a module. All right. So this one itself is a sensor, a raw sensor. So when it attach with the board and there are some resistor or capacitor electronic and this one, so this one we call it a module. Right. So there are 4 pin. One is the V in. Umar, right? Okay. Sometimes they call VCC. Sometimes they call it VDD. Sometimes they call it V in. Okay. Alright. So V in. So normally you will supply some voltage. So also depending on the manual or data sheet of the sensor. So in this case, the sensor can operate at 3.3 volt. Yep, of course we can use 3.3 volt from the MCU. And then the other one is the ground. And this one is SCL and SDA. Okay, what is mean? Alright. Inside this module have also the IC. Okay, inside of the sensor. Alright. One more thing that I'm not cover in this class. Okay, we have played around with analog, digital, and so on. One more thing, there is a pin named UART, and also there are pin named SPI, and there are pin named I2C. Okay, so the pin that you have see on this sensor temperature module, which is the SCL and SDA, is mean the I2C. Okay, this is the 3 pins, right? UR, SPI, and I2C is mean you to talk between between no MCU and the sensor, right? So let me explain it to you, right? Okay, this is your sensor. You want to MCU to talk with this. So one of the option you can use the protocol, we call it is I2C. Where is it? I2C. Okay, I2C here. Okay, and you want your not MCU to talk your PC, right? Your computer. So now it use what? It use the UART protocol. Okay, that what I you know. Okay, the other one is SPI. So if you buy another sensor, for example, I think ultrasonic. I think okay, this one like ultrasonic. So they use another communication named SPI. Okay, so it depending if you use a sensor or maybe you buy a module, right, that already have the sensor, so they will fix their what we call it their pin, whether you want to use the UART or SPI or I2C. It depending on this sensor that you bought. Okay, that is the one thing. In this case, it use the I2C. Okay, so far do you have any question regarding UART, SPI and I2C? I not cover into detail lah. Okay. Any question? You just bear in your mind, these 3 pins, UART, SPI and I2C is used to communicate between your node MCU and also the module. Okay. Any question, guys? Last but not least. Guys? No.
No, doctor.
Okay, good. Okay. Last one, I2C pin, SDA and SCL. So if you can see here, which one the SDA? Yep, at pin D1 and D2, SCL and SDA. Although that it also can be GPIO, it also can be I2C pin. So we're going to use these 2 pin. Okay, so let's go the MX. Okay, 90. Okay, before that, you need to install the library. Okay, so how to install the library? It's a simple. You go to tools and you go to manage library. Okay, I will share you this slide after class. Okay, share the slide. Okay. Where is it? MNS library. Hi, where is it? Okay, there. Okay. Now, after you go to tool and manage library, you need to find the library for this sensor. Okay, in this case, come on, editing list. Okay. Now, what you need to find, where is it? MLX 9064. Now, it's close this one, Okay, search MLX 9064. Okay. Oh, why? Okay. Now, what you need to do is you need to install Arduino library for this one. I already put here Arduino library in the other fruit shop. Okay. So in this case, yep, this one. You need to install this one. Okay. Arduino other fruit shop. So I just click install. So after you install, you will see it already installed. Done. You just need this library. Okay. Done. So just close. So let's create a new lah. Okay, let's create new. Okay. Now next. So what you need to do? Yep. Do the circuit connection. Okay. How to do that? Okay. That one. Okay. This one. Okay. Go to this. Okay. Not this one. Okay, zoom in. Okay, now VIN, here is the VIN. VIN is the orange. You connected to the 3.3 here. Done. Okay, done. And then the ground here, the what we call it, the red color connected to the ground here. Done. And then SCL. Okay, SCL, you see that pin D1. So is after this is SCL. Okay, D1 connected to D1 here. And then the D2 is connected, the last pin connected to D2. Okay, okay, done. Okay, we already connected all 4 pin. Done. Okay, alright. So let's write coding. So how to write the coding? Okay, I will show you. First, you need to include wire.h. What you can do is you can how to include okay, to how to include, I forgot it. How to include verify. Okay, you go to sketch. I will show you. You go to sketch, you can include library. So now you need the library I2C, right, which is wire. Okay, done. Cache, include library, and then you scroll a little bit, you just choose wire. Done. Okay. Now I click it 2 times. So now next is what is the how to do. Okay, this one. Right. Next. And then you need the other fruit, this library. Okay, you just go sketch, include library, and then you go to this one. It will show you after you have installed the library. So it will show you this one. So you choose other fruit 90614. Done. This one done. Okay. This one we can put it at this one first. Okay. Done. Done. And then after that, so you need to call this, okay, the function. Done. And then after that, yep, I just make it short one. Okay. Yep, copy and paste. Okay. Then you save at the desktop, and then project 1, this one, put number 3, temperature sensor. Okay. All right. For your information, this sensor will give you two readings. One is the ambient temperature, which is the ambient, right? One is the object. This is on what it will scan, right? That's mean, okay, I will show later. So what can we do is we declare a two variable here, and then we want to use the serial monitor so that we can see the output, and then you can write a word, right? Ada proof MLI test. So when you put the ln, that means after this word it will put a new line /n, and then you need to call mli.begins, and then this one is the first to what we call it, set up your sensor lah. Okay, and then after that you can call the function read ambient. It will give you the ambient temperature. If you read the object temperature, it will give you the object temperature. So we save it in this variable. Ambient, we save it in this variable. Object, we save it in this variable here. Okay. So for the serial print, you just want to check lah at the serial monitor. So let's hope this one is working. Okay. Alright. This is our sensor. This is the sensor that has been used in the what we call it temperature detector when you go to the mall and so on, right? To go to what we call it speed mart, right? Then we use this kind of sensor. Okay, let's wait. Now it takes time to upload. Okay. Okay. This is our last example. Okay. Hopefully we can end our class for today lah. Okay, done. Alright, we have done upload. Guys, are you still there?
Yes,
Yeah,
yes.
we're here.
Okay. Alright. This is the output. Okay. Right. So the important thing that we need to know is the object temperature. Now I put this sensor into my head. Okay. What is it, the value? 34. Wow. Okay. So this is the value, we call it is the real value. That's why after you got this value, you need to put some offset. Maybe you can put it 0.2, right? Some offset. This is the value when you want to apply this sensor, right? For your project. So you need to change this offset, right? You will see that when I put into my forehead, right? So you will see it will increase 0.2, right? Because of before that I see that 34, right? So it's not 0.2, right? Is it 2, right? 2, right? Okay. 2.0. Okay. Okay, I will again. Okay. Guys, do you have any question regarding this sensor?
Yeah, Doctor.
Are you happy now? Are you happy now?
Doctor?
Yes.
I have a question.
Yeah. What is it?
What's the difference between objective temperature and ambient temperature?
Okay. Ambient, that's mean it will detect surround this one. Surround this lah. That's mean I think maybe internally, right? So the object, that's mean it will detect if you put your hand here, it will detect this heat, right? Actually, this one is used it apply the same concept with this one, the same concept with the IR sensor. It also have the transmit, it also have the receive, right? But of course the IR sensor is very small lah, right? It apply the same concept. So when you put your object, for example my hand at here, right, you will see, right, the value. Okay, but the ambient will not change. You see, 28, 28. So do you get it? 28, 28, and so on. Okay, that is the ambient because I
So
open
we have
the
to,
air conditioning.
yeah.
Yep. Sorry.
So we have to calibrate the sensor.
Yes, yes, correctly. So now when I put the my forehead, what the value is it? 56. Okay.
Yeah, that,
All right.
that's it.
Normal temperature.
Yeah.
Now that's mean I can enter to the mall, right? I can enter to the shop, right? Normal temperature.
Normal temperature.
But can you imagine that I don't see any cases that we we show, right, not normal temperature, right? I don't see, right? Maybe they do something on this value, right? Can you believe, right? Right. So this is what we call it offset value, right? So some of the research they put some hollow there. I want to show, right? So they put some hollow there, so that when you scan your temperature here, okay, you scan the temperature here, so that's mean the IR sensor will, what we call it, will focus lah. That's mean uh, that's mean more focus, right, on this one. Okay, all right. So let's say I integrate with the IR sensor. When my forehead is IR sensor, it will scan. Okay, let's I edit this one. So it's the same thing. So you use the I put it the IR sensor again. Okay, IR sensor equal to D1. D1 already used. So I put it D5. Okay, D5. Okay. Now this one pin mode. Okay. Pin mode equal to what is it? IR sensor lah. Okay, IR sensor. IR sensor is the digital value. So now is input. Okay. Input T. Okay, done. So you do the same thing. Do the same thing. Okay. Integer sensor value equal to digital weight IR. There are something that not good with the Arduino IDE where you don't have the predicted words, right? That's mean your Arduino IDE cannot predict the word that you want to enter, right? If you use another software, right, another microcontroller, it can predict. That's the I call it. That's not good thing about the Arduino IDE lah. Okay, so now you can hide. So then anything will inverse. Okay, let's put all this thing. Okay. Now if your sensor become high, this one to tap you just highlight all and then you can press tab. Okay. Alright. Okay. Now if your sensor detect high, so it will print at the serial monitor, and then not print at the serial monitor. Okay. Let's do this. For that, so let's connect the IR sensor here. VCC. Now. Okay. Where is the sensor? Okay, this is the sensor. Okay. So in this case, VCC is purple. So 3.3 volt here. And then the one is ground here. And the one is D5. Oh, let it finish first. Okay, done. So D5 here. Okay. Yeah. Okay. Alright. So now let's open the serial monitor. Where is my serial monitor? Okay, here. Oh, so that's mean if we invert. So that's mean this one is low. That's my daughter. Hi, how are you? What are you doing?
Kappa.
Siapa? My daughter. For your information, I got class from 8:30 a.m. until now. I'm quite busy today. Okay. Alright. Done. Okay. Alright. So let's see. So now when you don't have any object, so it your it doesn't appear the value, right? The serial monitor, right? Okay. Now if I have the object here, you see, it will appear, right? Okay. So now let's recap. Okay. Of course, the when you have okay, let me zoom a little bit. Okay. When you have okay, this one, right? This is what you have been seen in the mall, right? Okay. Now this is my forehead. I'll make it to you. Okay. My hand lah. Okay. You see? 34. Is it normal or abnormal? Okay. So this is my hand or forehead. It detect. Okay. It will detect. If not, right? It will not do anything. Okay. If I put in my forehead, yep, 34. So this is the way that you need to adjust the distance of your IR sensor, and this one you need to adjust the offset. Okay. Alright. Done. This is enough for your project 1. Okay. Alright. How do you feel?
Good.
Sorry? Yeah, yes. What? What is it? Oh, that's mean, okay, that's mean the temperature, right? There are many value, right? Okay. So, what you can do is, you need to do like array like this one. Okay. For example, right? You need to put some what we call it, some array. I don't know how to write an array. Okay, maybe I can put it here. Okay, one more thing, right? Sometimes when you write a coding, right, you don't know what this means. Okay, there are some shortcut how to do that. You go to help. That is find in reference, which is Control Shift F. Okay, when you double click this one, you press Control Shift F. It will go to the this one, the library, right? Arduino, we go to float. What is it? Right, so on. It will describe you what is mean the float and so on. So right now I want to use the array. So can I put here temperature? I don't know how to write array in the Arduino. Maybe like this one. I don't know whether it work or not because I'm not using the Arduino. I'm more using on Raspberry Pi. So what you can do is for the temperature equal to I, okay, equal to then you will read the let's say we just focus on the object temperature. Okay, this one, right? So all these things. Okay, one more thing, if you want to comment all this line, you highlight that that one, then you press Control and slash. So it will comment this all this link. Control slash. Okay, done. So in this case, temperature I equal to this one, and then I equal to I plus 0. Okay, and let's say we put the integer I first, equal to 0, right? So if I equal to 5, and then you need to find the average. One more thing is you can find the average. So what you can do is what is it? Temperature. Okay. Object. Okay. Object variable. Object variable equal to temp I. Okay. Temp 0 is start from 0. Or 5, right? Let's say I put it on the 3 average. Okay. So plus 1 and plus 2. Okay. This is the way you write a coding lah. Okay. Now here. And then from this one, you can ask this one again. Then you equal to this one. You divide by 3. Okay. Okay, let me explain this one. Okay, first of all, you need you create an array. Anyone? Do you know about array?
Matrix.
No, sir. Okay, array. That's mean. Okay. What the difference between if I have three variable, integer x1, and then integer x2, and then integer x3. Alright. What is the difference between if I put it here is 3. Okay. So this one we call it array. This one we call it is a variable. So inside this array, it will have x1, x2, and x3. Something like that lah. Okay. The concept. Alright. So what is mean the x1? That's mean the x at the elements 0. It is like a metric number. It's like yeah, we learn the what we call it metric, right? So we have the metric 2 times 2, right? 2 times 3 or 3 times 3. Okay. This one we call it a 2D array. So this one, when I put it here, is we call it a 1D array. That means 1 times 3, right? 1 row times 3 column. Something like that lah. Okay. Right. So on this concept, what you can do is, so I use array which is named temperature, and then if the sensor is detect, right? So I will call the MLX read object temperature. It will give you the temperature value, right? Of course, this one I need to put a float lah. So because the reading in term of floating number. So at the first I put it here. Starting, okay. I equal to 0, starting first. So at the first I, which is equal to 0, right? So it will save, first reading, it will save to 0, okay? And then I will increase at 1 because I plus 1, right? So it will save at the temperature 1. And then after I equal to 3, and then I will average that value, okay? So let's see whether I can get it or not. Okay, so just call this one, whether it's working or not, this one. Compile first. I don't know how to write an array on the Arduino. I hope it will be like that one. Okay. This is one method. You can find an average, right? So that you can get an accurate value. Yeah, this is correct one. So let's upload. Guys, are you still there?
We are exciting to get the...
Okay. Sorry, we drag you a lot of time, right? Yeah, we got an question. Okay. Hopefully, this is the one option lah. You can find an average. Okay. Hopefully you can understand, right? My coding on what I'm going to put it here, right? This one. Okay. So let's see the output. Okay. Now, so I just test the IR. 1, 2. Okay, what happened?
I think because you said print abundant, not objective temperature.
Thank you very much. Okay, here. This one, I think after that it will increase. Okay. That's why when you write a coding, you need to, sometimes you just to correct only one line, and then you need to wait for 20 seconds. There's something lah that I want to tell you about this. What I feel about when I using the Arduino IDE. I don't like this one. It very takes so long, right, to upload your coding. Okay. You just change only one line, right? For example, you just change this one, right? Okay, done. Alright. Okay, where is it? Okay. See? Now it become average.
The I think should be inside the if.
Okay, I know. So this one after that equal to 0. I need to put it again. Where is it? A0. Again, this one need to be I equal to 0 again lah. We need to initialize it back. Okay, wait it read temperature. It read 0, 0, and then 1, 0, 1, 2, 3. Oh, 4 value. Okay, so let's start with 1. 0, 0, 1, 2. So this one will be 2. And then 0, 1, 2. Okay, 0, 1, 2, 3 value. Because it start from 0, then it divided with 3.0, done. And then we declare, and then we initialize 0. But why it increased? Go to 1, 0. 0, but this one is increased equal to 1. Need to check it back, right? Okay. This one is not correct. After is 0, now it increased to 1. That means this one I not equal to 0. Now if this one equal to 0, so should I put the I++ here? So we don't put it here. Okay. Okay. This is the way lah. When your hardware is ready, now it's time you to fine tune, right? To find the accurate value. Okay. I believe there are a lot of example, right? You can find on how to find the average, how to find the accurate value of the temperature sensor, how to find the accurate value of your data. Okay. It will take some a lot of time, right, to get the accurate one. Okay, so let's see whether it works. Okay, let's try to prove the concept. Okay, right. Okay, 9. Okay, done. Okay, take the average lah. You will see that the value almost same, right? You see? You got it? 90.6, 90.6, 90.7. Okay. Guys, is it okay?
Okay.
Okay. This is the way to get the accurate value, right? Okay. Yeah. How much is it? Not accurate. Okay. All right. I think that's it. Do you have any question regarding my lectures for today? Do you have any question? Okay, Alhamdulillah. So hopefully,
Alhamdulillah. Thank you so much.
yeah, hopefully it's clear to all of you. Alright, it is clear because I just show you a basic thing about the thing that you need to understand. And also I added the sensor. I hope that you can start to do the coding program. And also in this slide there is additional example, which is the DC motor and so on, which is I not have time to cover. So if you want to use the ultrasonic, yes, so I call it can use, but the ultrasonic it will detect between 2 cm until 450 cm, right? So if you want to use ultrasonic, you can go through on this slide. So this is the connection, okay, and so on. And then after that, this is the coding, right? So there is no library, need to call. So this you can run this coding and then you can get the distance here. And then another one, yep, this one is for another temperature, but it is not to detect your forehead. It used to detect the ambient temperature. Okay, this is the example. Alright, okay. So before I will end our class, so after that I will share this slide. So before that, last but not least, any question? Any question? Any question, guys? Who's that? Aliani apa? Ileana Aliani. Okay.
Thank you, Doctor. No question.
Okay.
Thanks.
Is it clear to all of you, guys? Sorry,
Yeah.
Yes.
I think I'm quite fast. Okay. Jennifer. Okay.
Yeah, okay, doctor.
Yeah. Sorry. Ahmed. Clear. Clear. Okay. Okay. Good. Alright, good. I hope that you got a skill how to do the wiring and also the coding. The coding you need to test by yourself lah. That's mean, yep. It will take us. That's mean it will take a lot of time lah. So how to get the accurate value and so on. Okay, that's it only to find the tune. But I think in term of you want to develop what we call it uh, okay, so I call it the temperature detector. I think it should be enough, right? This is the temperature detector, and also for the servo motor, and then you can attach with another IR sensor. Should be enough for you to do the hand sanitizer. Okay, alright. This pair and this pair, it should be enough. Alright. So next meeting, alright, we will learn about how to program the Blink, the mobile app here, how to program it on the next meeting. Okay. If you want to see that, is the Blink. Okay. So how to program so that you can see okay, you can see, yep, the input, right, the analog and so on, the push button. This is the basic one lah, push button and so on. Okay. Alright. Okay, we will learn to this how to control the Node MCU. Okay, we will repeat again. So how to control the servo, how to control the LED, how to control the how to display this value to this one. Okay. Alright. Hopefully you enjoyed in my class for tonight. Last not least, no question, is it? No question?
No سؤال.
Okay, sorry for that your time. So ah uh, yeah, I see. I know. That's why I don't want to record sometimes. It will take long. One hour, right? 1 hour and so on. It will take long time. I don't know. So which one is the good thing is if you can put into your into your Google Drive, maybe you can share the link. All right, maybe they can upload lah. Or if you if you want to okay. Yeah, it's okay, it's okay. It's okay. I'm okay with that. Okay, thank you very much, Ahmed. So in this case, we will end our class for today. Anything, any problem, you can WhatsApp me. So I will see you again. Maybe we will have class on this Tuesday or maybe not. Right? That's one I will discuss with